I'm going to use this rectangular piece of paper to create a kite and then show some properties of kites. So the first thing I'm going to do is fold it in half. All right, now that it's folded in half, I am going to draw in an isosceles triangle. I drew that in so that the longest side is actually on the fold of the paper, and now I'm going to cut it out. Once it's cut out, I'm going to unfold it, and I just created my kite. So the one fold is one of the diagonals, so what I'm going to do is draw in that diagonal and the one other diagonal. Now we're going to talk about the different properties that are created by those diagonals and the sides in general. Because I started with a scalene triangle before I cut out the triangle and created the kite, I know that my two adjacent sides on the top are congruent and my two adjacent sides on the bottom are congruent. Because it was scalene, I know those two pairs of sides are not going to be congruent because the sides of a scalene triangle are not congruent. Also, because the original triangle was scalene, that means that the top and the bottom angles are not congruent, but these two side angles are congruent. When I originally had the piece of paper folded, I do have these two congruent scalene triangles, which means the top angle of the kite is being bisected because those are corresponding angles of congruent triangles, and that goes with the bottom as well. So as you can see, the non-congruent angles of a kite are being bisected by the one diagonal. When we look at the diagonals, because this is drawn and cut to scale, we can visually see that the diagonals are perpendicular. And the diagonals are not bisecting each other, but one diagonal is being bisected by the other. So this diagonal that's connecting the congruent angles is going to be the one that's being bisected.